So I have to agree with you. Research in batteries, it's an incredibly exciting time because the demand we see is going up and up and up. Certainly portable electronics, like you said, power our laptops, our cell phones. But there are two big areas now that are motivating research in batteries. One is electric vehicles, and the adoption is projected to go really high over the next even 5 and 10 years. And in fact, there are some countries that have already set the date beyond which they're not going to sell internal combustion cars. They're going to be outlawed.
Whoa.
And the other application is renewable energy. So we've all heard of solar and wind, of course, but there's two issues. One is that they're intermittent, so that's a problem. But the second thing is the way the grid is established today, you can only put a limited amount of renewable energy into the grid because the grid today is you generate it and you use it. There's no place to put it. And storage, there is no storage today. And so I think that's another place where storage is going to be important to enable a larger fraction of the total energy consumed to be renewable as opposed to fossil fuel generated. These new applications demand new batteries. And the new batteries, really their function depends totally on new chemistries. So there's invention and discovery of the new chemistries, but then even perhaps, along with that, or perhaps even more importantly, to try to understand how do they work, if they stop working, what goes wrong, what limits their lifetime, and how can we adjust the behavior of the electrochemical system to really meet the need of the application. So, as I said, it's a very exciting time to be involved in energy storage research. The other area that's important to me is the whole environmental impact. What elements are we using? Where are they available on Earth? Are they broadly available? And of course, how toxic are they? So we've been very focused on elements that are widely available, that are Earth abundant, which often means low cost and non-toxic. As an example, one of the materials we're looking at is an iron oxide. And if
it's everywhere.
It's everywhere.
Right.
It's absolutely everywhere. And it's not very toxic. And so if there were a spill or something, it wouldn't be, a disaster. And so these elements probably are going to be more suitable for large batteries. I don't know if they're going to replace, our cell phone batteries. But large batteries are going to be where more of the environmental impact is.
Right.
So you're exactly right. As chemists, we can think about the entire life cycle of the product, not just focus exclusively on, no matter what it costs, no matter what it takes, let's make the best battery. We really need to be responsible, I believe, and think about where are the materials coming from, ultimately where are they going to end up,
Right.
And we can do our part then to ensure that the impact on the planet from the batteries doesn't offset the benefit of introducing renewable energy. So we've been thinking very much about multimodal approaches, how to probe materials and systems over multiple length scales to understand how those pieces fit together to better understand the functional chemistry when it's in its working environment. And the other tool that I'd like to mention is the idea of operando testing. And what operando means is that we take a battery and then put it in some kind of device. And most often we use X-rays, often synchrotron type X-rays. And then as the battery is working, we can probe it and watch what's happening. So we get not only thermodynamic information, but kinetic information. that if you just test the battery and then take it apart and look at the pieces, you can't
issue.
find. Yeah,
Right.
you can't find. So that was really the theme of the issue. You know, even if I wanted to select a battery for an application, how would I go about that? And I can tell you there wasn't one.
Ooh.
So,
Yeah.
so what I think the best place to start, really, you know, these days, is start at the internet. There are resources there, and I think there are some, you know, good articles. The Department of Energy website is a good place to look. You know, they've got a lot of information there. And one thing then leads to another. But I think for anybody who's interested, as they start reading, you just start finding more and more about it. But it is true, I think, that and I would say another thing, the field is complex enough that I'm not sure that a single text is even possible, really. Yeah.